In this video, we're going to look at a motion of a particle P, which does not have constant acceleration. We have what's known as variable acceleration, and because we have variable acceleration, the Suvat formulae that you know no longer apply. So it says a particle P moves on a path that runs north-south through an origin O. Its displacement st meters from O at time t seconds is given by S of t is t cubed minus 18t squared plus 16t, for t being between 0 and 15. It says find the initial velocity and acceleration, the times at which the velocity and the acceleration is 0, the minimum velocity, the times when the particle is at the origin, and the total distance travelled. Okay, so before we look at this, we're just going to look at this Geogebra app, which I will put in the notes of the video. Okay, so here we have a particle P which is going to move in this sort of direction, and this is a measurement of its displacement from the origin where it is at the moment. So to begin with, the particle is at the origin. So if we start, what we'll see is that it will go up and then go back down. Okay, and then it will go back up again, and it will end up somewhere up here after 15 seconds. Okay, so just reset that. If we put in the displacement graph against time and run the particle along both, so this time you can see the particle here. So here, this point is of interest, because here the velocity is 0, it's going to change. And this point is of interest because the velocity will change again from being negative to positive. So we're going to have here, for example, positive velocity, negative velocity, negative velocity, 0, positive velocity. So the acceleration is going to change. If we look at the velocity function, which is the derivative of the displacement function, we can see here we've got positive velocity. We get to this particular point and the velocity becomes negative. Okay, and we get to this particular point, it then becomes positive. So we know that here and here, for example, is going to change direction. We can see that from the graph. If we look at the acceleration, and we'll just reset it so it's both are at the beginning, we will see that it's a straight line running through this point here when t is equal to 6. Here, at this particular point, the acceleration will change from being very small negative to very large, a very small positive, and then increasing positive. So what exactly is happening? Well, the initial acceleration is minus 36 and the initial velocity is 60. But as the particle goes up, the negative acceleration is actually sort of getting smaller, but it's acting against the particle. And then at this point, it will make the velocity change. It's still negative, but then it's going to become still accelerating or decelerating here until it gets to this particular point where the acceleration will change from being in the negative direction to the positive direction, and then it will start to increase, and then that will overcome the negative velocity. See the negative velocity decreasing until we get to this particular point here. T is 10, sorry. I can see if I can get that. Let's see if I can do the arrow key. There we go. Oops, there we are. T is 10. This particular point here, the velocity will become 0, and then the acceleration will just forever increase and make it go upwards. Okay, so what we've got is a variable acceleration. Now, in order to so we'll just reset that and we'll just run it along it again. You can just see for yourself. Okay, you can play with this applet for yourself as well. So we've got variable acceleration. Acceleration is actually changes sign and increases, and therefore it sort of makes the particle eventually change direction. Okay, so its velocity, it actually gives us the direction whether it's positive or negative. If it's negative, it's going to start to go downwards. If the velocity is positive, it's going to start going upwards. Now, it's quite easy to go from displacement to get velocity. All we need to do is differentiate the function, and then to get acceleration, all we need to do is differentiate velocity or do the second derivative of displacement. So we can now answer the questions. We're going to find the initial velocity and the acceleration. We knew what they were from the Geogebra App, but doing it algebraically, S of t is t cubed minus 18t squared plus 20t. V of t is the first derivative, or ds dt, or we can use function notation s dash of t. So v of t will be 3t squared minus 36t plus 60. And then we want v of naught, the initial velocity. So we can very easily see that that's going to be, if we substitute 0, we're just going to get 60 meters per second. Therefore, the initial velocity was 60 meters per second. But a of t is dv by dt, so we differentiate again, or v of t, or differentiate displacement twice. So if we differentiate this again, we're going to get 6t minus 36, and then a of 0 is going to be 6 times 0 minus 36, which gives me an acceleration minus 36 meters per second. So this is positive, it makes it go upwards, but this is negative, so it's going to eventually make it sort of go slower and eventually make it change direction. So this will be acting against the velocity here. Okay. So the initial acceleration is minus 36 meters per second squared. So now we have to find the times when the velocity and the acceleration is 0. So to find when v of t is equal to 0, we just put 3t squared minus 36 plus 60 is equal to 0. There's a common factor of 3, and then this factorizes quite easily, becoming t minus 2, t minus 10. That's going to give t is equal to 2 and t is equal to 10. So if we go back and look at this, we can see that the velocity is 0 here at 2 and 10. For the acceleration equal to 0, we just need to put 3t minus 36 is equal to 0, 6t is 36, and then t is 6 seconds. So, and again, we can get that from the graph. Just going back to the graph, we can see here when t is 6, the acceleration changes from being negative to positive. Okay, the minimum velocity will occur when the derivative of the velocity is equal to 0. Well, that happens when at t is equal to 6 seconds. So if we put t into 6 into here, we're going to get v of 6, which is 3 times 6 squared, minus 36 times 6, plus 60, which gives me minus 48 meters per second. Again, that happens at this particular point here. We can just see it is about minus 48, as we just found. Okay, to find when the displacement is equal to 0, we saw from the graph that happens in 3 places. We need to solve t cubed minus 18t squared plus 60t is equal to 0. It's a common factor of t, so it leaves t squared minus 18t plus 60. Doesn't factorize, so we either use a quadratic formula or some quadratic solver. So either t is 0 or t squared minus 18t plus 60 is equal to 0. So using the quadratic formula, we get minus 18 plus or minus 18 squared minus 4 times 1 over 60, 2 times 1. That on your calculator will give you 18 plus or minus 2 root 21. Most modern calculators will work this out in third form for you, all divided by 2. 2 goes into 18 9 times, and the 2 goes into that once, so we end up with 9 plus or minus root 21. That will give t is 0, t is 4.42, or t is 13.6. And again, we can see that from the graph. 4 point something, 13 point something, and obviously at the initial place. Right, now, let's actually go to this. Okay, let's just reset this. Now, in order to find displacement from the velocity graph, we're not being asked to do that, we're being asked to find the distance, but we'll look at that first of all. Displacement is given by the area underneath the velocity graph and the t-axis, or the horizontal axis. So if we start that, we see here that the displacement by the end of that point is about 56, and goes down, and then it becomes negative. So the area under here is underneath. Okay, so it's all related to calculus, this. Okay, and then the displacement becomes going to become positive from here to here. Okay, so in order to find the final displacement, which is 225, notice it's ended up at 225, you just need to integrate the curve between 0 and 15 directly, and that will give you that. But what do we want to do if we want to find distance? Because this total distance travelled is not, we cannot just integrate between 0 and 15, because we know that's going to give me an answer 225. Well, to do distance, we'll just go back again, so just reset. If we click now to do the distance and start, what happens is that we need to consider this bit underneath the graph here as positive. So we need to work out this one. Okay, it's a little bit slow because there's quite a lot running here, but we'll get there eventually. Okay, so we'll need to work out all this one. Okay, if I just remove displacement for a moment, so we'll need to work out that area, plus that area, plus that area. Now we can get this area by integrating between 2 and 10, and then just taking the absolute value of it, or integrate from 10 to 2, the reverse integral, and just add. We can decide. So the total distance travelled by the particle is 735, whereas the displacement is where it finally ends up after 15 seconds in this case, which is 225. But that isn't the total distance it travelled, because remember, it went up, it went down, and then went back up again. Okay, so to do that, we need to do a little bit of integration, but it's fairly straightforward. The distance travelled is going to be from 0 to t of the absolute value of the velocity function. So that makes, wherever it is negative, we'll just make it positive. But we'll need to split up the function between 0 and 2, because that's where it is positive. So we do 3t squared minus 36t plus 60. That is going to be that one there. And then we need to do the absolute value from 2 to 10 of 3t squared minus 36t plus 60 dt. Or you could just forget the absolute value and put 10 down there and 2 at the top. Okay, that's going to be that bit there, which will give me that bit there if I take the absolute value, plus this bit here from 10 to 15 dt, which is going to be this bit here. Okay, so we don't need to actually integrate it, because that we know this will give me the displacement formula, which was given in the question. So these are one things I need to just work out. Okay, so just work these out individually. It's a slight mistake there. So this should give you, it should be 18. Right, just putting 2 in here will give you 56 minus 0. We can get that by just scrolling this back a bit. Let's reset it. So if we go to 2, oops, a little bit too far there, 2, go back to 2. Okay, we get 56, but we can put it into our calculator. Minus 0, then the next one will give me minus 200 when I put in 10. So let's take this to 10. Oops, sorry. Okay, let's go back with the arrow keys. Oops. Okay, so we've got minus 200 there. Minus 56 from before, and then 225, which is the final place, minus 200, If we work that out on a calculator, we're going to get the total distance as 737. So this gives us a way of working out distance, okay? But if we wanted just a displacement, all we would need is take the displacement formula and put t is equal to 15, and we'll get the answer 225 straight away. So this has been a video to look at what's known as variable acceleration, given the displacement, velocity, finding the velocity and the acceleration, and then being able to work out displacement and the total distance travelled. I hope you've understood, and I thank you very much for watching. And I'll remind you the Geogebra app will be in the notes of this video. Sorry this video is so long. Thank you very much.